Welcome, future navigators. Today, we're diving into one of the most classic and essential skills in celestial navigation, finding your ship's position using the North Star Polaris. This is a core competency for any mariner, a skill that connects you to generations of sailors who looked to the stars. This exercise, straight from the NAV for course, will teach you how to determine your latitude with incredible accuracy. Our mission is to plot our ship's position using a pole star observation, getting within 2 nautical miles of the correct answer. We'll be working in a chart room environment, using a nautical almanac and our wits. This isn't just theory. It's a hands-on skill that proves you can plan a passage and determine your position anywhere on the open ocean. Here's the scenario. It's January 3rd, 2011. You're underway in the open sea. Your dead reckoning position is latitude 23 degrees north, longitude 60 degrees 53.2 minutes west. At 17:30 local time, you take a sight of Polaris. Your sextant shows an altitude of 22 degrees 55.8 minutes. Your chronometer reads 21 hours, 28 minutes, and 10 seconds, but it's running to minutes and 26 seconds slow. Your sextant has an index error of 2.9 minutes off the arc, and your height of eye above the water is 52.5 feet. Your task is to calculate your precise latitude and the azimuth of Polaris. Ready? Let's break it down step by step. First, we need to find the exact Greenwich Mean Time, or GMT, of our observation. We'll start with the chronometer time, apply the known error, and convert our local zone time using the zone description. Precision here is key, as every second counts. With our accurate GMT, we turn to our best friend, the Nautical Almanac. We'll look up the Greenwich Hour Angle, or GHA, of Aries for the specific date and hour. Then, we'll use the increments and corrections table to adjust for the exact minutes and seconds of our observation. Remember, this correction is always added. Next, we calculate the local hour angle, or LHA, of Aries. This connects the celestial sphere to our specific location on Earth. It's a simple calculation. We just apply our longitude to the yacht of Aries. West longitude is subtracted, east is added. Easy. Now let's work with our sextant reading. We start with the sextant altitude, which we call H's. The first thing we do is correct for the instrument's index error. Since our error is off the arc, we add it. If it were on the arc, we'd subtract. This gives us our observed altitude. But we're not done correcting. We were standing 52.5 feet above the sea, so we need to apply the dip correction for our height of eye. You'll find this in a table right at the front of the almanac. Applying this gives us the apparent altitude. One final correction to the altitude is needed. We apply the main altitude correction from the tables to account for atmospheric refraction. This transforms our apparent altitude into the all-important true altitude, often called HO. This is what the sextant altitude would be from the center of the Earth with no atmosphere. Now comes the magic of Polaris. The calculation is unique and surprisingly simple, thanks to special tables in the almanac. First, we take our true altitude, HO, and subtract a constant 1 degree. This is a standard step for every Polaris sight. Next, we apply 3 small corrections known as AO, A1, and A2. These are found in the Polaris tables. AO is based on the LHA of Aries you calculated earlier. A1 is based on your latitude. And A2 is based on the month of the observation, the best part. All 3 of these corrections, AO, A1, and A2, are always added. After applying these 3 corrections, the number you have is your final, calculated latitude. It's that straightforward, but we're not quite finished. We also need the star's bearing, or azimuth. The Polaris tables make this easy too. Simply enter the table with your LHA of Aries and your latitude, and you can directly find the azimuth of Polaris. This is crucial for plotting your position line on the chart. And there you have it. You've successfully taken a raw sextant reading and, through a series of precise steps and corrections, determined your ship's latitude at sea. This process, from calculating GMT to applying the final A to correction, is a fundamental skill. It combines your knowledge of time, celestial mechanics, and practical observation into a single, reliable position. Mastering the Polaris sight is a rite of passage. It's a dependable and elegant way to confirm your latitude in the Northern Hemisphere. Practice this method, get comfortable with your almanac, and you'll have a timeless skill that will serve you throughout your entire career at sea. Thanks for joining this navigational journey. If you found this helpful, give us a like, share it with your fellow mariners, and subscribe for more deep dives into the art of navigation, fair winds, and following seas.